Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are working on the summative questions as part of the culminating tasks for the year end. It's question number 2 from the summative questions, and for clarification, yes, this is question number 2 from the May 2013 version, not the older version. So let's have a look at the question. A school play ran for 2 nights to audiences totaling 1,390 adults and students. The combined total of ticket revenue was $4,285. Adult tickets cost $4, student tickets cost $250. If the ratio, ooh, interesting, the ratio of adults to students was 3 to 5 on the first night and 2 to 3 on the second night, how many students attended each night? So hopefully when you read a question like this, it's pretty obvious that this is not a quadratic equation and it's not trigonometry, which means this is going to be a linear systems question. In other words, we're going to be identifying two variables, setting up two equations, and solving for those two variables using either elimination or substitution. But first, obviously, we need to think carefully about what our variables are going to be. There's a lot of information about this question. We have, let's piece out the information we have. So we have total number of people, and that's adults plus students. We have total dollar amount. We have ticket prices, and we have ratios. Now, this ratio bit is interesting. So let's spend a bit of time talking about ratios, and that might give us a clue as to how we're going to actually create some variables and turn those into equations. So for example, we're told in this question that the ratio of adults to students on the first night is, what is it? 3 to 5. So we have adults and students, oops, in the ratio 3 to 5. Now, let's make sure we really clearly all understand what that means. It does not mean there were 3 adults and 5 students, although maybe there were 3 adults and 5 students. But that's not what it means. It means that for every 3 adults, so here's 3 adults, so every grouping of 3 adults, there were exactly 5 students to match. So that means there could have been 8 people, 3 adults and 5 students, or let's do this little trick I like to do with my applied students, or maybe there were this many people, 6 adults and 10 students. It's still the same ratio. There's still 3 to 5, but now there's more people. So another option again is that there could be 6 adults and 10 students. Or, again, just to make sure everyone really is very clear about the concept of ratio, and you'll see where we're going. Maybe there were this many people. 3 adults and 5 students, 3 adults, 5 students, 3 adults, 5 students, 3 adults, 5 students, and that would be a total of, well, I've got 4 groupings here, so 12 to 20. So the question is, how many adults were there and how many students were there? We really don't know. But we do know that there is a common relationship between the number of adults and the number of students. We know that if there are 3 adults, there are 5 students. So one thing I like to think about is when I'm looking at ratio, I think about the fact that there's a multiplication factor. So for example, here I multiplied by 4, 3 times 4 is 12. So here I had to multiply by 4 as well, 5 times 4 is 20. Earlier, I multiplied by 2 to get those numbers. So you can pick any number you want and multiply a ratio by it and get a possible answer. So for example, what if I multiplied by 20? Well, if I multiplied by 20, there'd be 60 adults and there would be 100 students. Now, the problem is, of course, that in this actual question, we don't know what the multiplication ratio is. So that leads us to think about perhaps identifying a variable that represents that multiplication ratio. And that's actually what we're going to do. I'm going to say, for example, I'm going to let k be the multiplication ratio. And don't worry, I'm going to write this out formally in a second. But if k is the multiplication ratio, then I have this many adults, 3K, and I have this many students. And now I'm starting to see where there might be a ratio, or sorry, where a variable might come into play. And similarly, on the second night, when we're told that the ratio of adults to students is 2 to 3, so again, think about what that means. If I have 2 adults, I have 3 students. If I have 4 adults, I have 6. If I have 10 adults, I have 15 students. And if I have, oh, let's pick another letter. Let's go with P. So if I have this many adults, 2 times P, then I have 3 times P students. And again, now I can actually use these as numbers because 2P is an actual value as opposed to the ratio 2 to 3, which is just a ratio. So if that makes sense, let's go ahead and define some variables here and then see what's going to happen. So I'm going to let K be the multiplication factor for the first night ratio. So let K be the multiplication factor for the first night's ratio. Now again, that means, and I'll put this immediately, therefore, um, we know that 3K adults and 5K students attended the first night. Now, if this makes sense to you, the rest of the question is going to follow very easily. If this doesn't make sense, you need to maybe either go back and watch again or come and get some extra help. But again, all I'm doing is I'm saying that a ratio itself cannot be put into an equation. But once I've identified this multiplication factor, this K value that we don't know, this is just a number. It's 3K. It's a coefficient and a variable. I can do math with that. So we've defined K to be the multiplication factor for the first night. So similarly, let P be the multiplication factor for the second night. And again, right away, what does that mean? Well, it means therefore 2P adults and 3P students attended the second night. Because again, the original ratio was 2 to 3, so now it's 2P to 3P as values. So what do we know? Okay, well, 3K adults and 5K students attended the first night. 2P adults and 3P students attended the second night. So that means that total attendance, I can talk about total attendance because there were 3K adults. Oops. On the first night, I had 3K adults and 5K students. On the next night, I had 2P adults and 3P students. And altogether, we know, again, if you look at the question, that there were 1,390 students, sorry, people. Now let's collect like terms. So I've got 8K and 5P equals 1390. So right away, hopefully you can recognize, wait a minute, that's an equation with two unknowns. If I can find another equation involving K and P, then I can solve. Well, again, look back at the question. The other information I know is the price of tickets and the total revenue. So let's think about that. Um, so let's do revenue. Every adult ticket was $4. So on the first night, I had 3K adults. On the second night, I had 2P adults. And for all the adults, I made $4 a ticket. Next, for students, I had 5K students and then I had 3P students, and each ticket for them was $2.50. So this is the number of adults, and it was $4 a ticket. This is the number of students, and it was $2.50 a ticket. And altogether, all that money combined was $4,285. And again, if I clean this up and collect like terms and so on, I'll have another equation involving K and P. So let's do that. So 12K plus 8P plus 1250K plus 750P equals 4285. Collect like terms. 2450K plus 1550P equals 4285. And there is my second equation involving K and P. So here I have an equation that talks about the number of people who attended, and here I have an equation that talks about the revenue. So let's put them both on the same page. So I have 8K plus 5P equals 1390. And then 24.5K plus 15.5P equals 4285. There you go. Two equations, two unknowns, solve. So again, at this point, you can shut the video off and try solving it for yourself, or you can, follow along or welcome back. So how are we going to solve? Well, I'm always a big fan of solve by elimination. That's just what I prefer. So I'm not going to play around and try to find common multiples. I'm just going to straight away take the first equation and multiply by 24.5, take the second equation and multiply by 8, and then I'll be able to subtract to eliminate the k's. So my calculator is handy. I have, 24.5 times 8, 24.5 times 5, and 24.5 times 1,390. Now I'm going to take the second equation and multiply by 8. So again, those match. 8 times 15.5 and 8 times 4285. So I made my k's match. So if I subtract, I'll be eliminating. 196k minus 196k, eliminated. 122.5, so I have negative 1.5p, and hopefully I get a negative over here. 34055, blah, 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 blah. So I get negative 225. And then divide both sides by negative 1.5, and I get a value for p of 150. Yay! Little smiley face for me. And now that I know p, let's go back and find k, and I'll use equation 1. So again, here's equation 1, 8k plus 5p equals 1390, and now I know that p is 150. So let's solve for k. 8k plus 5 times new p, which is 150. New p, I don't know why I said it like that. So 8k is 640. Divide by 8, k is 80. So now we know p equals 150 and k equals 80. Now, obviously that's not the end of the question. The question said, well, let's review what did the question say. It said how many students attended each night? Okay, well, number of students. 5k students attended the first night. And that's all I need to answer. So let's go back to where we had K and P. Number of students who attended the first night. Oh no, my pen. Hold on. Who attended? Who attended? Wow. The first night is 5k. Therefore, 5 times 80. Therefore, there were 400 students who attended the first night. So I hope that makes sense. A really interesting question that we certainly didn't do during this regular school year. But your understanding of ratio and general numeracy is obviously an important concept. Anyway, hope that was useful. Hope that was helpful. If you have any questions, ask anybody, post online, etc., etc. Okay? Take care. See you at school.